Okay, so lesson 4. It's pre-cal review, trig review, I should say. Radian measures, trig ratios, quadrant signs, trig expressions. All of the, how do we do our basic trig stuff? Okay, the basic trig stuff that you need to know in calculus that you just have to be able to do. So, remember when we measured in trig, we sometimes measured in degrees, but a lot of times we measured in radians. I will tell you up front, calculus focuses more on radians. We are usually in radians as opposed to degrees. So like when you talk calculator, you're going to want to have your calculator in radian mode most of the time. Okay? So, a little bit of review about radians. If an arc of a circle has the same length as a radius of the circle, the central angle is said to measure 1 radian. So the definition of 1 radian, the arc of a circle has the same length as the radius of the circle. And that is 1 radian. So if you recall from the beginning of trig last year, do you remember how to go from degrees to radians and radians to degrees? It is this, about throw 180 in there. So in order to go from degrees to radians, you're multiplying by pi over 180. So I always think to get to radians, I have to multiply by pi over 180 because I want to put the pi in there. To go the other way, so to go from radians to degrees, here I want to take the pi out because that's a radian thing. So it's 180 over pi that we're multiplying by. Okay? And then I have it in my notes here. I'm going to kind of put it in here just to kind of explain a little bit about the whole idea of what a radian is. Notice it says the arc of a circle. So if we have the arc of a circle, so from radius to radius, that arc of the circle has the same length of the radius of the circle. So basically, if all 3 of those are the same length, then that central angle measures 1 radian. So right down in here is the measurement of 1 radian. Okay? So that is your definition of a radian. I don't know how much we focused on that yesterday, but if the arc length equals arc of the circle is the same length as the radian, or as the radius, then the central angle is to measure 1 radian. Sorry, radius, radian, I get tongue-tied. Okay, example 1. So how do we convert 40 degrees to radians? You can also just think of it as 40 pi over 180. I know the zeros cancel and I have 4 over 18, but we know 4 over 18 reduces to 2/9. So this is 2 pi over 9. Could you come up with a decimal if you need it? Yes. Okay. I have written down that it is 0.6981. And again, it just depends on what you're doing. If you're on a calculator-less problem, you definitely would leave the 2 pi over 9. Okay? And that's, I don't even think I ever read the rest of the directions. Write as a value of pi. So when we say write it in terms of pi, that's 2 pi over 9. Write as a decimal, that is the 0.6981. Okay? If this was degrees, we'd put a little degree bubble to label degrees, right? Because this is radians, we typically don't label. Okay? I mean, yeah, you could say 2 pi over 9, it's radians. But radians are officially considered unitless, is what they say. And so, you don't usually see a label written on it. Radians, I'm just putting the note here, are considered unitless. Okay, so if you see something in measurements and you don't know if it's degrees or radian, degree will have radians. You just, if there's no label specified, you assume that it is radians. Guys, who does he want? Is it Abby or Shively?
Well, it's both, but I wanted to ask you, wanted to say to them if they could please come down to the high school presentation room. If you have 5 minutes left, whenever they get done, so they can register.
So they can start registering?
Yeah, but it's Shively, I apologize, Jacob, but Shively, Mast, and is there one more that you said was maybe absent today?
Weber just got sent home to quarantine.
That was who I knew there was a third one. So
if you would have caught her this morning, she was here, but she's gone for the next.
It's a laborious process to set it up. So those are the only two. So you can just go to the high school presentation room. Bring your iPad with you. It should be about 10 minutes, 10, 15 minutes. Okay.
Where did our insurance guy go then? Did he get kicked somewhere else?
Christy Overly said she was going to email everybody. Got moved up to the high school conference room.
So our insurance guy is here this week, enrolling, unenrolling, doing changes. And he started off in the middle school room. But that's Barb's holding room when she's quarantining people. The holding cell, yes, if you will. So I had the 8 o'clock appointment this morning, and so then after my 8 o'clock appointment, they needed their room, so I escorted them down to the presentation room. So it sounds like Ivy Tech just took over the presentation room. And so he's gotten kicked out. Poor guy's gotten kicked out again. So, okay, as I was writing, radiants are considered unitless, and I mentioned that if there's no label, you assume radiance. So what I was getting ready to say, if not specified, unit is assumed radians. Yep, pretty much. And I don't know if you were in here or not. I'm not sure when I said it. Most of calc is radians. It's rare that we work in degrees. So, Ross, I know you were in physics last year. You can relate to this. My calc kids struggled because they needed their calculator in radians here, but in physics, you guys need your calculators in degrees. So they were constantly going back and forth. So it's a struggle in the years when we have physics and calculus. This year, pretty much just keep it in radians. I mean, occasionally we might use degrees, but once we really truly get into calculus, you don't usually mess with degrees. You have to know your radians. So, okay, moving on. Trig ratios. How much do I need to say about SOHCAHTOA? Probably not much. You learned that back in geometry, right? So SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. That sounds familiar, right? And that is all based on wherever the angle is. So obviously it would never be the right angle, but like for instance, here's my theta. If this is theta, then in reference to theta, my opposite is across from it. Adjacent is the leg that touches it, and hypotenuse is always the hypotenuse. Okay, spot the typo in the next line. Cosecant is 1 over sine, cotangent is 1 over cosine, and secant is 1 over cosine. Yeah. So these are our reciprocal functions. Cosecant and sine are reciprocals, right? So cosecant is 1 over sine. Cotangent is a reciprocal to tangent. So cotangent is 1 over tangent. And secant is a reciprocal of cosine. So secant is 1 over cosine. Okay? Sounds familiar, right? Remember the chart? Notice it's only radians in that chart because that's mostly what we use. But for reference sake, what are the degrees equivalents? Pi over 6 is actually 30 degrees. Pi over 4 is 45 degrees. And pi over 3 is 60 degrees. And I'll be honest, I'm the teacher, but I still tend to default to degrees sometimes. I have to think carefully. So, now, do you need the triangles or can you just fill the chart in? I personally have my way I just fill the chart in. But don't forget, there's nothing wrong with drawing your triangles. Do you know what triangles I'm talking about? Yeah. 30, 60, 90 and 45, 45, 90. So in a 45, 45, 90, the two sides are the same. So for those two legs or sides, we use ones, and then the hypotenuse is square root of 2. For the 30, 60, 90, the short leg, so opposite 30 is 1. The hypotenuse is twice that. And the long leg is square root of 3 times the short leg. Okay? So those triangles, you should be able to come up with those. And those can fill in your chart if you have to. But I would get to the point where you just know the chart, right? So if we have sine as the first column, I always know sine of 30 or sine of pi over 6 is 1/2. And then I tend to remember my diagonal. Cosine of 60 is also 1/2. Go to your triangles if you need to. Cosine of 30, square root of 3 over 2. That also means sine of 60 is square root of 3 over 2. What about sine and cosine of 45? Square root of 2 over 2 is how I write it. If you go to the triangles, you're going to get 1 over the square root of 2, right? But rationalize it as square root of 2 over 2. Tangents. Again, you can go to the triangles, but I, for tangents, tend to use the fact that tangent is sine over cosine. So, in the first row, if tangent is sine over cosine, your denominators of 2 will cancel. You remember me talking about this the other day? It's 1 over square root of 3, but that rationalizes to be square root of 3 over 3. In the 45s, you're dividing something by itself, so tangent is 1. And the tangent of 60, well, if you will, it's the reciprocal of the tangent of 30. So that was 1 over square root of 3. This is square root of 3. Square root of 3 over 1, which is square root of 3. The more we work with that, you've just got to come away with what you can do with it. I don't care if you use your unit circles as reference for right now. But as soon as test 1, you cannot use the reference circles on test. I will never allow it on a test because that's how I have to train you. So, but for all means, use it to double check yourself on homework. That's fine. Use it to make sure you know what you're doing. Okay, some evaluate examples. Evaluate. Sine squared of pi over 3 minus the tangent of pi over 4 plus the cosine of pi over 6. Nice thing is we have the chart here, don't we? So, what is the sine of pi over 3? Square root of 3 over 2. And then we're going to have to square that. Okay? I'll do all the math here in a moment. Minus tangent of pi over 4. You're right, I'm wrong. I don't know what I was doing. I obviously did not read tangent because I wrote down the total wrong thing. So tangent of pi over 4 is 1. Cosine of pi over 6? Square root of 3 over 2. Okay. What is the square root of 3 over 2 quantity squared? 3/4. Still going to be minus 1 plus square root of 3 over 2. How can I clean that up? Yeah. And there's two different ways we could express this answer. You could just worry about cleaning up like terms. What is 3/4 minus 1? So one way to write this answer is negative 1/4 plus square root of 3 over 2. Or, what if we did get that common denominator? Well, what would be the common denominator? We'd have to have 4, right? Which means this fraction has to be multiplied top and bottom by 2. So I'd say negative 1 plus 2 square root of 3 all over 4. Okay, I put that together in my head. I hope that's okay. I mean, it would be negative 1/4 plus 2 square root of 3 over 4. Put them together as one fraction. And this comes down to understanding equivalent, what's equivalent. I'm big about that, especially in calculus. You have to know what's equivalent to your answer. Because if you see, again, this is more just trig review. But if you see a multiple choice question like this, and you come up with your answer like this, and they have the answer like this, you have to know how to get the equivalence there. Okay. Secant of 30 degrees plus cosecant of pi over 6. What is the secant of 30? Okay. Because it's a reciprocal of cosine of 30, right? So I'm going to write it as 2 square root of 3 for the moment, but we will rationalize that. Plus, what's the cosecant of pi over 6? The reciprocal of 1 over 2, which is 2 over 1, or in other words, 2. Yes, you should be in the habit of rationalizing. Square root of 3 is in the denominator, so we're going to multiply by square root of 3. So 2 square root of 3 over 3 plus 2. I left my answer as that. The other option would be to make it 2 square root of 3 plus 6 all over 3. But I left my answer as that right there. Okay. Sounds familiar, right? I'm getting ready to flip to the back page, Ethan. So you might as well just pick up there with us. I don't think we did anything crazy on the front page. It was all pretty basic review. Yeah. Okay. 4 quadrant signs. Certain trig ratios are positive in certain quadrants. Remember? What do you remember? Okay. All students take calculus, right? So all is all. What's students stand for? Sign. And if sign is positive, that also means cosecant. The reciprocal is positive. T stands for tangent. And it also means cotangent is positive. And C stands for cosine. And that also means that secant is positive. Okay? You slept a lot since then, but you remember that, right? Okay. Now we're going to get a little trickier. Evaluate 2 sine of 19 pi over 6 plus 3 sine, and that is of negative 4 pi over 3. Really, since there's a negative there, it should have parentheses around it. It just doesn't. Close that since Ethan's back, before the lunch scramble begins here. Yep. This is a good place for you to walk back in, Ethan. This is where it gets tougher. Maybe you remember it just fine, not saying you don't, but this is the tougher stuff we have to think about. Okay, so we know 2 is 2. That's a piece of cake. No stress there. Sine of 19 pi over 6. We have to figure out where 19 pi over 6 falls, folks. Now, think about 19 pi over 6. What do you know about 19 pi over 6 in reference to once around this circle? Yeah, 12 pi over 6 is once around the circle, so this is, yeah. So I'm going to kind of put some work up here that you need to remember. This is just me finding, what's the word? Not reference. Is it coterminal? Is that the vocabulary word we use? When it's just another name for the same angle. So if I take 19 pi over 6, and basically what am I doing? I'm subtracting off 2 pi. Then that puts me at 7 pi over 6. And so really what we're going to be doing here is 2 times, I'm going to say the sine of 7 pi over 6. Now we're still going to have to figure out where that is. But I just want you, that's what you have to think. So 7 pi over 6. Can you kind of place where 7 pi over 6 is going to fall? In the tangent quadrant. That's good. You guys came up with that? Because we know right here is pi, right? And so in terms of pi, that is 6 pi over 6. What we need is 7 pi over 6. Right? Now, we need that reference angle. How far is 7 pi over 6 from pi? How far down is that? That is pi over 6. So our reference angle is pi over 6. So we have to think about what is the sine of pi over 6 in quadrant 3. So what is the sine of pi over 6? 1/2. Because we're looking at pi over 6, but it's in the third quadrant, sine is negative here, so this is a negative 1/2. So this is coming back to you, because this is important, right? Have to be able to do some basics like this. If you want to think of this as a basic, but it kind of is. Okay, plus 3. Got the 3 for you. Times sine of negative 4 pi over 3. There's 2 different ways you can do this depending on your comfort zone. Well, yeah, I mean, you can figure out it's going to be a reference angle of negative pi, or of pi over 3, just based on it being thirds. But we've still got to know where this lands so we know what quadrant we're looking at. It is going to be in sine. Now, how did you figure that? Okay, so it sounds like Ethan started here, and because it's negative, he went over here, right? This would be negative 3 pi over 3, which puts negative 4 pi over 3 up here. So that's one way to look at it, and that's perfectly fine. The other option is, if you are not comfortable with that negative, could you add to it and make it positive and go from there? Maybe you guys would prefer me not to do that. There's a lot of looks like, whatever. Okay, well. Okay, because what I was going to say is kind of like what we did earlier. If you need to, take negative 4 pi over 3, and this time I'm going to add, what is 2 pi? That is 6 pi over 3. And then you end up at 2 pi over 3. Does that still land in the sine quadrant, though? It does. So I don't care which way you do this. It's equivalent. No one cares because it comes down to you knowing how to do it. But regardless, you're going to end up here in the sine quadrant, whether you call it 2 pi over 3 or whether you call it negative 4 pi over 3. What is the reference angle then? We're going up how far from the x-axis? Pi over 3. So what you're really doing is you're finding the sine of pi over 3 in quadrant 2. What is the sine of pi over 3? And is that positive or negative square root of 3 over 2? It's positive because it's sine in the sine quadrant. Does that ring some bells, what we just did there? I mean, we still have to finish it up, but that's important stuff. If you recall last year, that stuff was quite a challenge for you guys, so. Okay, 2 times negative 1/2 is negative 1 plus 3 times radical 3 over 2. 3 square root of 3 over 2. I'm going to leave it as that. Negative 1 plus 3 radical 3 over 2. You could say, make it